Hello. I see some people have got here early slash on time.
Hello, hi.
Hi, David. I'm gonna, of course, wait for a few minutes past the hour before I start actually with the lecture. But I'm just gonna be looking around, see who's here and see what's going on, and hopefully it's all good. If you have any questions before the lecture begins, feel free to let me know. You can put it into the chat. You can speak about it. Um, Other than that, yeah, we'll just be waiting around a few minutes for it to start, for people to arrive, and then we'll start. Mhm. You can see that some more people seem to be joining. Just want to let you know that I'm here, and we'll be starting the lecture proper in a couple minutes. It's customary in Latrobe to be starting a few minutes past the hour to give people time to, get into the actual moment instead of doing everything on the hour. I am also using this time to get used to the interface.
Hey guys, can you hear me?
Yep.
Yes,
Hi.
we can.
Yep, cool.
Yeah,
Yeah,
what's
that's
happening?
good. Just checking microphone, I guess.
Cool.
Okay. Um, I will be waiting for the full 5 minutes pass before I start the lecture, but hello, hi, welcome everyone. I am Brandon. I'll be taking the subject. I'll be your lecturer, and I'll be taking the labs, and I will be repeating this information once it's 5 minutes past, of course, but hi. If you have any questions, you can feel free to put them into the chat at any time. Um, and since we're getting started, you can also have ask any questions beforehand, but we will be starting the lecture in 1 to 2 minutes.
Maybe just a silly housekeeping question from my end, but I can see some names, but my name is showing up as my student ID. I'm not sure how to change that.
Hmm. I think that's a settings option inside of the Zoom application if you're using that. I think
There is a three dots in your profile. If you click on there, that says rename. So where you see your profile, the picture, and then in the whole
Ah,
of it, there's the
yes,
three
I can see it
dots.
now.
Just
Thank
rename. Yeah.
you.
Yeah.
Thank you so much.
excellent. Learning together. Okay, I think that's about time. So, more officially, hi, I am Dr. Brandon Victor, and I'll be taking this subject, this term for subject Artificial Intelligence Fundamentals. Welcome to the first lecture. This will be a 2 hour lecture from 5 o'clock till 7 o'clock, and we're going to have a break in between at around 6, just to make sure that we can go to the toilet, get a drink, whatever. Don't have to do the whole 2 hours straight. We have some break in between. So, with that being said, let us begin. Are you able to see the lecture slides? Can I get someone to confirm that they're able to see that?
Yep.
Yes.
Awesome. Thank you very much. Okay, so as I said, this is lecture one. We're going to start with some subject admin. We're going to be talking about, you know, what is even in the subject? What are we talking about? What is the LMS? What are the assessments? What are you going to expect from the subject? Um, just want to note that you guys, so this lecture will be recorded, so everything that happens in this lecture will be recorded, and that's going to be put onto LMS for anyone who can't actually get to the get to the lecture. I believe I'm not 100% certain. I believe the chat will also be recorded, but I can choose to upload that or not, and I guess I'll leave it up to you guys. Maybe I can do a poll towards the middle whether you would prefer to have the chat included or not. Um, I can see either way. In any case, if you have a question, not during these lecture times, then the best place for that would probably be the Q&A part of the forum on the LMS, and I'll show you where that is in part of this admin setup part of the lecture. Um, Alternatively, you can email me, and I'll show you how to get my email address as well. Um, and if you are during these lectures, it would be good if you have any questions, especially if you've read through the content already and you have a question about a specific part of it. It'd be good if you waited until we get to that part of the lecture and then you ask a question about the content, because these lectures are meant to be recap rather than directly teaching the content fresh. So we will start will, as we always do here, with an acknowledgement of country. So La Trobe University and myself, we acknowledge that this lecture and probably all of the participants are located on the lands of many traditional custodians of Australia. We recognise their ongoing connection to the land and the value, and we value their unique contribution to the university and wider Australian society. I don't know about you guys. I am currently on the Wurundjeri lands, the Wurundjeri people, and I pay my respects to the Indigenous elders, past, present, and emerging, and I will extend this respect to any Indigenous participants joining currently online. So, hi, I'm Brandon. It's me. You're going to see me in both the lectures and the labs. I'll be taking all of the lectures and all of the labs this semester, unless for some reason I am unable to, in which case I'll have a colleague take over. This subject covers fundamental AI concepts that's supposed to set you up for either future study of AI at La Trobe or just general knowledge of how these things work, how these, everyone's used them now, the LLMs, the big generative AI, is to set up how they work and how to work with them. We'll be talking about specific terminology. We'll place these algorithms within a hierarchy so that you can get a good idea of how these terms relate to each other. I'm sure you've heard of them, LLMs, generative AI, AI in general, and we also talk about machine learning and deep learning. That's what the subject's about. I hope that it will help you in your use of AI and your further studies as well. So this subject is structured for 6 weeks. Every week there will be a 2-hour lecture recap, which is where you currently are. This is the first one. That's going to be recorded and put onto LMS, as I said. And separately, there is a lab/lab recap, depending on how you want to approach it, for 2 hours as well. And there's 3 sessions for labs, and you only need to go to one of them. Those will be in a separate Zoom call. There is one from 7 o'clock till 9 o'clock this evening. And if you're in part of that one, we will be swapping calls so that the recording is separate on the system. Okay. So that's every week you have to do those things. And then there will also be 3 assignments that you will have to do for the subject. And we'll talk about due dates and what those assignments are in a moment. So these lecture recaps, the way we want to run them is we want you to have read all of the module course material before coming to these lecture recaps. So at this point, hopefully you have all read through all of module 1 because we're going to be recapping all of module 1. So in these sessions, basically I'll be summarizing the information from module 1 and then answering any questions you have about it. The idea is not that this will be the first time you'll have seen it, you'll have read through modules. So this is module 1. The labs, I think it goes through Allocate Plus. I'm actually not entirely certain for this subject. In any case, there are the different lab sessions, and if the lab sessions get too full, I will have to double check which one people are supposed to be in. But otherwise, I am happy for people to come along to whichever one suits them fine, suits them best. And that is, it says 5 to 7. 7 till 9 on Wednesday, and Friday 5 till 7, Friday 7 till 9. These are separate lab sessions. You only have to go to one. No, okay. So to recap, your weekly flow is you need to go through the learning material on LMS, the whole of, in this case, module 1. Then you need to attend the lecture recap session, and then you need to have the lab session, and that's your normal week. If you are unable to do that at the particular times, please make sure that you catch up before the next week, because if you start to fall behind, it becomes harder and harder to catch up. So please be diligent about keeping up on the weeks that you need to do the content. So here are the topics that we're going to cover the week by week. We're going to start by talking about the AI, modern AI concepts, modern AI thoughts, how we think about it, what it even is, how we run it. And then we're going to, for the second module, take a sort of big step back and talk about machine learning fundamentals, the algorithms that underlie these large models. And we're going to look at the bare bones, the really deep, uh, simple underlying ideas, which will then build up throughout the modules to mostly talk about the LLMs and how you will use them and how you should use them. And so we start with those fundamental ideas of how machine learning works, and then we look at AI for computer vision because it's a good stepping stone along the way. We look at exactly how large language models work and how multimodal models work with those LLMs. And of course, we talk about responsible use of AI because it's very important that you know when to use AI, and when not to. So the assessments, you'll notice on there's 3 assessment dates. This information, by the way, is on LMS, and I'll show you with that at the end of this admin section. There are 3 assessments that you will need to do for this subject. The first assessment is a smaller, fairly simple one. It is a zero-shot image classification trial. You will have it's already on LMS. You have a Colab notebook that you need to work through, and then once you've done that Colab workbook that you've notebook that you've worked through, there's a quiz on LMS that you need to do, answering questions about that. And you need to do both of those things. Assessment 2, similar to assessment 1, you have a notebook that will be provided to you. It's not available yet, but it'll be available soon, where you're going to train a custom model for image classification, and you're going to try different hyperparameters, and then you're going to write a report about that, and then you're going to upload the report to LMS. The third assessment is the sort of more creative one. You're going to basically make a pitch for a product or a use case for AI, combining together some AI tools, and you're going to make a video for that, maybe an 8 to 10 minute video for that, which will be uploaded onto LMS as well. The specific dates are on LMS, and I'll show you where this is, and it'll be in this table or on the assessments tab, and we'll have a look at that in a moment. Of course, these are your assessment. These are what your grade is dependent on, so it's very important that you, of course, do these assessments and don't leave them to the last minute, of course. I am an educator. I have to tell you, I have to remind everyone, you should start them as soon as you can. You're, of course, paying to be here, so you should engage with the subject as much as you can. So the subject is about AI and about responsible use of AI. So, of course, we want to sort of model that a bit, and we allow you to use some amount of AI to help you in the assessments, but there is sort of sort of slightly different uses across the different assessments. So for the zero shot and for the assessment 1 and 2, the zero shot classification and training a custom model, we say that you can use AI for planning. It can help you come up with ideas, but none of the written text is allowed to have come from an LLM. You must have written your own answers. You can talk to it about what you should do, what you could try, but you can't use it to polish your text, for example. The third assessment is a little more open because it's a creative application of AI, we're more okay with you having much more of a back and forth about planning out your own project using AI and, of course, giving you ideas. But similar to the previous ones, obviously your words should be your own, and you cannot use AI to generate a video, for example. If you are unsure about whether what you're doing is okay or not, my policy is that there's no fault. Like I guarantee you that if you tell me what you're doing, you will not lose marks if it is something you are not supposed to be doing. The idea is that we want to be able to set what you we want you to be able to know what you're doing is correct or not without fear of something going wrong. Obviously, if you're using it incorrectly, that would be considered a form of cheating. And of course, the other forms of cheating are not allowed. You're not allowed to copy from other people. You're not allowed to pay someone to do your assignment. You're not allowed to let an AI write all of your answers to your assignment, etc. So again, if you are unsure and you just want to double check, please let me know, describe what you have done with the AI, and I will be able to let you know whether that's acceptable or not. And if it is not, it's an opportunity for you to change it, and it will not be lost marks if you talk to me before submission. After submission, that's it is what it is. Before submission, talk to me about it. All right, so hopefully you know about it. Presumably everyone knows about it. But just in case you don't, let's have a look at the LMS page for the subject because everything you need to know about the subject is on the LMS page. That's where all of the content is. That's where all of the information about the assessments is. So let's just make sure we know what that looks like. So hopefully now you can see the LMS page, the homepage for this. Let's make sure that we're looking at it as a student. This is your LMS page for the subject, and it has a number of tabs to go through. And I find it useful to be able to see everything. So I'm just going to go through each of these tabs, not just the modules, but every single one, just so that you feel comfortable, you know where everything is and what it's there for. So the first one is the Study Essentials tab or section, and this is general information about studying. It's not even about this subject. It is just general information included in every subject about studying at La Trobe. The second one is about the subject. It is a high-level view of the subject, and if we go into it, you will see the subject schedule that I showed earlier with those due dates here and what we're teaching at each module. It has the subject learning guide, and it tells you this high-level information about the subject as a whole. Back to the home page. This third one is assessments, and this is where you read and download your assessments. You have the AI acknowledgements, you have the instructions, and you have whatever else you need to do. So assessment 1 is a quiz, assessment 2 is a submission, assessment 3 is a submission. On this page, you'll notice that there are 3-day short extensions. You can access this page and you can become a member of it if you want a 3-day extension for your assignment. So that's the assessments tab. Live sessions tab, of course, shows information about where we are currently. So this is the lecture recap where we currently are. And then here are the different lab sessions. All of the lab sessions will be the same, except that there will be different people in them. So I guess there'll be slightly different things discussed in it. But in general, the labs will operate as we all come in. And then if there's general questions, I'll answer those together. Otherwise, you'll be working on the labs. And if there's a specific question, I will want to make a breakout room so that we don't bother everyone else unless it's something that I think everyone should hear. And then I'll bring it back and talk to everyone about it. Otherwise, the labs are all basically the same. Um, the fifth one is Teacher Connect. So this is how to contact a person, like contact the educators. That's me, myself down here. I'm the lecturer, and Victor. But theoretically you can also contact Josh, the subject coordinator, Dr. Joshua Millward. If there's something about subject admin, especially, you should probably contact Josh about that, but I can direct you either way. So you can contact me. My email is here. But otherwise, if you want to ask a question about the subject, I do recommend putting it into the subject Q&A, which is this one here, because, and as you can see a couple of people have put stuff in there, because what you put there is actually useful for everyone, right? So if you have a problem, maybe somebody else has the same question, you can have a look at what other students are asking about and what the answers to those parts are. The last one is student support. This is another sort of general tab. This is information about general student resources, about how to get help if you are struggling with mental health, something like that. You can uh, get some information here about that, technical support, etc. So that is all of um, the tabs, the important tabs before the content. The rest of the tabs are just the content that you're supposed to read through. So I'll reiterate, before this lecture, ideally you have read through all of this, starting from this topic one, Introduction to AI, reading through, and you would go topic one, you'd read through, do any exercises, and then watch any videos, and then at the bottom, how did we get here, etc. Going through, reading through, doing all the things. Um, I think that covers everything on the LMS page. And let me know if there's anything,
Uh,
um,
yeah,
yes,
Dr.
about
Dr.
the others.
Victor, just putting my hands up here. Just wondering, in
You can call me
regards to
Brandon.
in regards to the LMS, I've been
Hmm.
trying to find a download button for the modules. Is there one that exists?
There is no download button. You're expected to view the content entirely within the web browser and go through the pages in your web browser.
Understood. Okay, thank you.
Yeah, good question. Thanks for that. Is there a way to mark the section of content as done? Actually, there should be. Um, Actually, that's a good point. Maybe I'll edit it if it's not. So we can edit this so that there's marking done on these. I will do that. I'll make it so that you can mark done on each of those sections, because obviously it's nice. There is, to my knowledge, no friendly mobile app. I think you can only really you can go to this page on your mobile, of course, but it's not going to look so good. There's no specific app for it. You'll
Yeah,
just
we
have
can
to use
use
the
it. We
browser.
can use Moodle. I'm using Moodle.
There's a Moodle app.
Yes, yes.
Oh my. Well, now I'm learning something. Excellent. Okay, so it would be a Moodle app because this LMS is Moodle, um, which is a common base software that universities use, and this is called Moodle. So Tin, if you could put a link to that, that'd be great. For the
Yeah, I'll do that. Yeah.
Yeah, awesome. Thank you very much for that.
Yeah. Now I'm driving, so I can.
That's fine. So whenever you're ready. All right.
Yeah.
That is all the admin stuff. If you have any more admin questions, then you can feel free to send them through either email or on the subject Q&A. We're now going to start actually talking about AI. All right. Um, okay. So for there'll be a little typo here. So this is for the rest of the hour. We're going to be talking about introduction to AI, so the basic AI concepts, as well as the basics of the Python programming language. The next hour, we'll be talking about some of the uses of LLMs AI and some basic data structures that we use in computing and AI specifically. So this, the intended learning outcomes of this part of Module 1 is we want to make sure that you know what the term AI means to some degree, at least give a definition for it that you can use. And we want you to know how it relates to other common terms, other similar terms, machine learning and deep learning. And we want you to know some general uses of AI. And then separately, we want you to know some of the basic syntax of the Python programming language so that you can edit and run basic Python programs. And I'm going to say this a bunch. Um, you're not expected to write Python programs in this subject, but you are expected to edit small amounts and then run some Python programs in Google Colab, which when you come to the lab, I will be going through how to get started with that. But you'll be running Python code in the labs. And so you need to basically know some basics of the Python programming language. All right. So what is AI? I'm sure you all have heard many definitions of AI, many different ideas of what AI actually is. Um, the concept itself behind all the definitions is quite old. Um, you can, depending on how you count it, you could say that the old stories of golems from thousands of years ago, more than 2,000 years ago, um, is an artificial life form that has some kind of intelligence. Uh, in this subject, we're going to use a sort of descriptivist definition. Instead of trying to prescribe what it should be, we're going to use a definition that uses, yeah, nice. Um, it sort of encompasses what people have meant when they have said AI, because there's been fairly different meanings of AI over the years. And we're going to find it as any computer algorithm that appears to show some level of intelligence. And what's important about this is often when computer scientists are talking about artificial intelligence, they're not claiming that it is very intelligent, but they're claiming that it has some level of intelligence, even if it's only got a little bit of intelligence, right? So computer scientist researchers and information technology hype merchants might be talking about artificial intelligence. What they generally mean is that it is a computer program that is acting in some way intelligent. Importantly, again, they haven't defined how much that intelligence is. They leave it up to you to decide how much. So those ideas are very old. They've been talked about since before we've had computers. And even in the 60s and 70s, the sort of modern idea of AI being a very clever computer program actually was being formed in sort of the public sphere and researchers even in the 60s and 70s. Yeah, like Excel linear regression. Is it intelligent? Probably not, but maybe some people might argue that it has some sort of intelligence because it can tell us something new, but who knows? So different algorithms over the years have been popular, and usually whichever is the most popular algorithm within AI has been considered the most intelligent or the most like artificial, the most artificial intelligence. You label that algorithm artificial intelligence the most often. And recently, as of maybe 2012 or maybe 2022, depending on how you count it, the most popular algorithm has been deep neural networks. So this subject about AI is largely focused on the deep neural networks algorithms. However, AI as a concept and of a suite of algorithms is much broader and older than just deep neural networks. Even though deep neural networks, or the base neural networks algorithms, have been around since the 60s, and they've just been improved and tweaked and improved and tweaked. But the basic idea has been honestly quite similar to those first versions. So we have several terms that we might talk about, we might encounter out in the wild. We have artificial intelligence, we have machine learning, we have deep learning, and we have generative AI. And this is kind of like a nesting situation where all generative AI is a form of deep learning, all deep learning is a form of machine learning, and all machine learning is a form of artificial intelligence. But that, of course, means that not all machine learning is, so not all of AI is machine learning. There are some algorithms that are AI which are not machine learning. So machine learning, we're going to be basically going down this hierarchy. So we're starting this module talking about artificial intelligence in the broad sense. And then the next module, we'll actually start talking about machine learning. So that second layer down, that's module 2. What is machine learning? How does it work? What are some examples of it? Um, and then we'll move on from machine learning onto deep learning and then generative AI as the modules progress. So machine learning, we can think of it as it's just one way to create an AI algorithm by letting a computer learn the patterns from data. So we give the computer a bunch of examples of how to do something, and the computer learns how to do it. That is the basic principle of machine learning. And that does not require deep learning. That is a very simple thing. In fact, we would say that linear regression in Excel is actually a form of machine learning because it is learning a relationship, that linear relationship, from data. So machine learning can be very simple, in fact, and that's why we start there. Deep learning, um, however, is a special kind of machine learning, and it is using machine learning on the deep neural networks that I mentioned. So neural networks are a form of machine learning, and when you have many layers in your neural network, it becomes a deep neural network, and training those deep neural networks is called deep learning. This is basically the most popular algorithm, I would say pretty confidently, in images since 2012 and in text since 2017. These have been wildly successful. These are what power the LLMs. And then at the deepest level is that at the inside of deep learning, this kind of deep learning is the generative AI, like the LLMs, the image generators. These are deep learning. The main difference is of scale. It is deep learning scaled up to many GPUs at once, many machines at once with a lot of processing power. So AI algorithms, they've been around for quite some time. So especially if you use that expansive descriptivist definition of basically any algorithm that looks like it's got some kind of intelligence, we've been using computers and automation to do somewhat intelligent things for us for quite some time. Search engines, for example, recommendation systems, so what to watch next on YouTube, what the algorithm on social media is a kind of intelligent system, right? It's hard to write down a set of rules exactly for it, how it should work. And it learns from data to be able to give you those recommendations. In the future, we're seeing it being used increasingly in healthcare, software development, and finance. These are these are spaces that AI is currently being used, and as you've probably experienced and seen, it does seem to be sort of being put into everything, especially these modern LLMs. However, I do want to reiterate, we've had system automation of various forms, which could be called AI, for quite some time in computers. Although we're not going to go too deep into it, I do want to talk about the hardware that goes underneath these AI systems. We won't be covering anything about how these GPUs work, but it is important to note that we will be running our AI algorithms on GPUs. So GPUs, it just have sort of a coincidence of history that both computer graphics and AI algorithms use many simple repeated operations, which it makes it very good to run on a GPU and not so good to run on a CPU, which is better at various CPUs are better at various sequential steps, whereas GPUs are much better at many repeated simple steps. And they can run like 100 times faster than a CPU on those sorts of tasks, which AI does. And you'll see why in the subject. And I also want to mention about this, which is pretty important. What we do in this subject is we're going to be actually running some real AI models, some very small LLMs in Google Colab. If you wanted to use, I guess, the big, good frontier models or something like that, you would need to be running those models across multiple GPUs and across multiple machines. And that can get very difficult to organize, very difficult to run. And so you have these cloud providers or cloud platforms, and all a cloud platform or cloud provider is doing is they have a data center somewhere and they're letting you rent some of their computers in that data center or across different data centers. And they buy up a bunch of GPUs and CPUs and hardware and all of that and all the RAM, so that you can just rent that from them for a little bit of processing when you need it. Often this is cheaper and easier for people to run AI systems rather than having to try and source all the different hardware, manage the hardware because things break, that sort of stuff. The cloud providers do all that for you and you just rent it from them. That's what you would want to be using if you want to deploy your own big AI LLM model in the real world. We're just going to be using smaller versions on a free resource. So why learn about AI? It's kind of everywhere. Do you really need to learn too much about it? Well, um, and of course the current interfaces are designed to be maximally user-friendly, right? You just type something in, right? What's there to learn about? Well, it's being used more common in industry and in everyday life, and I personally think that having a better understanding of AI is going to help you know what to use it for, what not to use it for, um, what sort of dangers exist, as well as what you can really use it for in many different ways, because you'll have heard many different things are AI and you can do many things with AI. We're going to be looking in the subject at uh, your interaction, like how you interact with the AI to get it to do what you want. And so it's good to sort of get a bird's eye view of how that works. And that's what we're doing in the subject. So yeah, when you use AI responsibly, it can improve productivity, but when it's used irresponsibly by companies deploying, often by companies deploying something that maybe they shouldn't, people can get hurt. So you should know about how to evaluate AI systems for what can be a problem. So we'll talk about this more in the later modules, but I do want to sort of hammer on this a bit more that it can be an incredible tool. And just like the high level issues we want to think about is first, outputs can be incorrect. We should assume that they could be incorrect, and we need to plan around the fact that they could be incorrect. And we need to be careful when we're reading outputs from LLMs because it could be incorrect, it could be biased, it could be misleading us in some way. So when we're reading text from it, we also need to think critically about what the LLM is telling us. And the second thing we need to talk about is AI systems, even if they're working perfectly, they could be used for unethical purposes. Computer systems don't exist in a vacuum, and we should be considering how our automation is affecting other people. So that's another part that we're going to be talking about that, but more details on that are going to be later in the subject. Okay, that covers that section there. I'm just going to look at the chat and see if we've got some questions. Seems some question. I'm going to answer those. Okay. What do they mean when they say an LM model is 744 billion parameters? It means just that the LM model has a bunch of parameters. This is the weights of the model describe how the model works. They are how the mathematics that go on underneath, how they're calculated. And so if you have 100 billion parameters, that means that there's 100 billion numbers stored in a file somewhere that's going to be loaded up and then used to multiply and add with your inputs to come up with the answer. And that will make more sense later on in the subject. We will be talking about that exact concept across multiple modules. So module 2, we'll talk about what is a parameter, what does that mean? And then module 4, we'll talk about how that's used in an LLM. I think it would be useful for courses to be developed to assess and address the security gaps in vibe-coded products. Yes, we do talk a little bit about that, but I also think that there should be it's kind of an emerging field, honestly, cybersecurity using AI systems. What are the processes you need to follow? Although I will note that a lot of it we already know these processes, and I think that the dangers are when people kind of hope that the AI will solve all the problems and they sort of discard existing processes. So we have existing processes to make sure that we have good software that has fewer security issues with good testing practices. And if you just think, oh, the AI is going to get it right, obviously that sounds stupid, but people will sometimes do that. You go, oh, it looks right, so it's probably right. So that seems to me to be one of the bigger issues with the current AI landscape, and that's kind of why why we're talking about this using AI responsibly in this course, because we want you to know to not trust it implicitly, right? Practically, how possible is it to write code for LLMs? For example, 744 billion sounds like a lot of lines of code, and I'm unable to imagine just the time involved. All right. It is not a matter of typing code for 744 billion. It is letting the computer learn. That is why we talk about machine learning and what enables it. In fact, the code to write it, you'll see in the labs, the code to make a 744 billion parameter model is actually very small. It's just repeating. That's why we talk about the GPUs doing small repeated operations. It's just the same thing repeated and getting the computer to automatically learn those things for us. And you'll see that in the labs. And so, yeah. All right. We need to get on to, if any more questions come through, I'll be skipping them because we need to get on to the Python basics to keep to time. I'm hoping to have a break in 15 minutes. So the Python programming language that we're learning for this subject, you're going to be learning just some basic syntax to understand it. But let's start with why we're even talking about the Python programming language. Well, the Python programming language is basically the de facto standard being used for running AI projects. But why is it being used for AI projects? It's because Python programming language is a very readable language. It's very easy to get started, and so it has sort of a vortex effect that pulled in researchers who wanted to very quickly prototype AI systems. And so they started using Python, so they started making libraries for Python, and so everyone uses Python for the AI systems. AI is you can use neural networks and deep neural networks in other languages, and in fact, it's moved into C++ to be more performant, but Python is still the default one that pretty much everyone uses. So it's a very readable language. It means that you can look at it and sort of get an idea of what it's doing, even if you have no programming experience. So if you look at this Python code here, can I get a laser pointer? Cool. This Python code here. If you just read it, you can pretty much have an idea of what it's doing. Let's have a look through it. It says for item in store inventory. If the item stock is less than 2, print low stock for item name. And you got some weird plus thing, and you'll look at exactly how that works in the lab. But it's pretty straightforward. We can probably figure out what this is about, for each item in the store's inventory. If there's less than 2 of it, then we're going to display a message to the user, and it's going to go through. And so this means that Python code generally is pretty easy to read, and that's why we're using it. And the other big reason, as I said, is that sort of large ecosystem of libraries and modules and other code that other people have written that we can use for not just AI models, but for computing metrics, drawing graphs, for a bunch of different things. Python in general is a popular language and has a large ecosystem. You can find learning resources about it very easily, and you can, oh, sorry, maybe I'll turn off the laser pointer if you're having problems. Okay. How do I turn off? Uh, can I? Okay, it's off. Cool. All right. Sorry about that. I didn't realize. All right, laser pointer is off. No more screen artifacts. Yeah, so the Python programming language has a large ecosystem of lots of different modules, which is other people's code that you can use because of its popularity. And so it's got that vortex effect. There's a lot of learning resources. And so it's a very nice language to just get started with and learn. So in this subject, I have said this before, I will continue to say this. This is not a programming subject. We will not be asked to write Python programs as a whole, but you will be asked to write a little bit of very small snippets of Python code or edit Python code to make Python programs run in the labs. You need to know some basic concepts, some basic syntax rules, and so we're going to go through 5 key syntax rules that you need to know for the Python language for the lab. So, syntax rules. Let's just get our terminology straight from the beginning. Syntax rules are the rules for how the computer reads the Python code to understand what is being communicated to it. And we need to learn those syntax rules so that we can correctly communicate to the computer what we want it to do. This is the basics of programming. This is the basic of any language. All languages have a syntax which describes how the language understands, or how the computer understands that language, understands the pieces of it. And these are the different pieces which we will be talking about here. Comments, literals and variables, expressions, import statements, and calling functions. We're going to do sort of 3 in 1 to start with because they sort of go together. We have comments, literals, and variables. If we look at this snippet of code here at the top of the screen, we have 4 lines of code. We have 2 lines of comments and 2 lines of what's called assignment to variables. The green part, this green text, which will probably be green for you when you're writing it in the lab. These are comments. This is notes for whoever's reading the code. The Python language basically ignores this. It doesn't provide any instructions to the computer of what to do. It only tells the reader what's going on. So in this code, we're going to use Python code to keep track of our money. That's a note to the person reading it. Python just ignores it. Then we have literals. This is literally the text that is on screen. It means what you see, which is different to variables, which are not literally what you see on screen. They are a representation of something. You can think of variables as named boxes, which can hold a value. So if we look at these lines of code again, what's happening on this 3rd line of code is we are creating a variable called money and wallet, and we're using the equal sign to assign the literal value 64.20 into that variable. So think of variables as boxes that hold something, and literals as literal values which we push around and put into those boxes. So the syntax of this line goes name of a variable, in this case money and wallet, equals, this equals is important, some thing on the right-hand side. In this case, it is a literal value of 64.2. And so these are 2 lines that both follow that same syntax. Variable equals value. You'll see this a bunch. This is the syntax it always has to be. If you try it the other way around, it won't work. If you do 64.2 equals money and wallet, Python will throw an error and say that doesn't make sense. Doesn't make sense. I can't do it. Separate to these literals, I said that the syntax is variable equals some value. Separately, you can write down what's called an expression. You can think of expressions as being somewhat similar to what you would put into a calculator. So if you wanted to calculate 4 plus 5, you can do 4 plus 5, put that into a calculator, press equals, and it'll calculate a result, right? An expression is basically doing that, sort of putting it into a calculator, except instead of only being able to put in numbers, we can put in other things which have the value of numbers. So in the previous section, we said money and wallet is equal to 64.2. So we can just write a piece of code like this. This is not a full line of code. This is just a snippet of code. this bit of code here, you can do money in wallet minus 1.2, and that'll take whatever value is in that box, in that variable money in wallet, and it will subtract 1.2 from that and produce the result of that calculation. So if we wanted another line, which we'll see further on, sorry, I'm swapping back and forwards, and I'm sorry, it's too much. Another line of code we'll see in a moment. We can capture that result of that calculation and then store that in a different variable if we wanted to, right? So this is a snippet, and this snippet can exist anywhere. So that's an expression, and you'll see more of that in the lab and in what we're talking about. And we're running a little bit low on time. So the modules, and we're going to talk modules and functions. So a module is a collection of code. It's also called a library or a package. They have different names. For the purposes of this subject, you should kind of treat them as the same thing. They're just some collection of code that is written by somebody else, and then we're going to use that code that somebody else has written in our projects. So in order to use a module, you have to import that module, and you have to write a specific line of code that just says import some module. That collection has variables and functions in it for you to use. Now, functions. So a function is a similar idea, but it's much smaller in scope. It is a specific set of instructions that exist somewhere else, or indeed you can write your own functions. It's a self-contained block of code with a specific set of instructions which you will call in order to execute those instructions. So that's a key word that we use in programming. When you tell a function to actually execute, that is, the name of that action is calling that function. So when we talk about code, if we talk in the lab, I'll say, how do you call a function? And we'll look at the syntax for how you call it. What I'm saying is, how do you make that function execute those instructions? And again, that function might be something that's written down in the lab. So a lot of the labs will have functions defined in them. And it might also be inside of a module. So if you go to use the math.cos function, which I'll show you, is a function that lives inside of the math module in Python. So a module can contain many functions, but a function just does one thing, right? A function is just one thing that it's supposed to do. The syntax for importing a module is just import that thing, import math. And the syntax for calling a function is the name of that function and then opening a round bracket. Okay? So whenever you see import something, that's importing a module, and wherever in any part of the line you see some sort of text, in this case math.cos, and a round bracket with nothing in between the text and the round bracket, opening round bracket being after the text, that is calling a function. In this case, it's calling the math.cos function. And in this case, we're calling the math.cos function, and we have these brackets have to be matched. And inside of those brackets is something that the function should operate on. And so if you're familiar with trigonometry, when you perform cos, you need to perform cos on the opposite over hypotenuse, I believe it is. So adjacent over hypotenuse. I always have to say SOHCAHTOA, whatever, I can't remember it. So the adjacent over hypotenuse, or it's of an angle. No, that's the inverse. Yeah, I'm getting it wrong. This is the angle, cos of the angle, cos of the angle. So we've got the cos of the angle. So we're passing in an angle in radians, math.pi divided by 4. That's what we're doing the cos on. So the cos function is running on this math.pi divided by 4 angle. And that's it. That's it for the Python. In this case, is the argument math.pi divided by 4 also existing within the math module? Is that why it starts with math dot? Very close. The math.pi, the pi is part of the math module. The /4 means divide it by 4. So that's an operation. So this is actually an expression here inside of these brackets to calculate something. Remember how I said that an expression is just sort of can be in the middle of a line? this is an expression that says go to the math module, find the pi variable, divide that variable, the value in that variable by 4, and then the result of that is what goes to the cos function. So it's a very good question, Nish. All right. You'll get more practice with this in the lab when you decide to do, whenever you have that. So labs this week, you'll get more practice with these. You're not expected to write Python programs. You're expected to write a little snippets of Python code or edit some Python code. So to summarize, AI is any computer algorithm that appears to show some level of intelligence. In this subject, we're going to sort of cover the AI landscape in a fairly broad stroke to build up to LLMs. And we will be using Python as a tool to interact with AI models. Thus concludes the first part of the lecture, the first hour of the lecture. This is that's that. So we're going to have a 5-minute break. So I'm going to start a timer, not a stopwatch. So you feel free to get up, walk around, get a drink, go to the toilet, whatever you want. Or if you want, hang around and ask some questions. You can leave and come back, whatever you like. We'll be continuing on in 5 more minutes with the next part of the lecture. We've got a question where to find the lecture slides. After this lecture, or tomorrow, maybe later tonight or tomorrow, I will be putting the lecture slides onto LMS in PDF form. It'll be in the, for each module, there'll be the content, the lab, and then the summary section. I'll put it into the summary section. The recording of the first hour will also be on LMS. Since you're here, I might as well show you. So on the LMS page, if you go to home, under live sessions, we have the time, 5 till 7 p.m. And then the recordings and resources, I'll make sure that you can access the recording. So the recording will be for the both hours, but it will be in this section here somewhere. I'm not sure exactly what it'll look like, but it'll be here, I promise you. Again, might not be tonight, it'll be by tomorrow sometime.
Hi, Brendan. It's Mira. Can you hear me okay?
Mira, I can hear you perfectly fine.
Okay, cool. I just want to ask, like, if you're for the first assessment,
Mhm.
can we start this after the first lecture, or do we have to wait until the second lecture
Well,
in terms of the
it is
material?
due next Friday, so you should absolutely be starting that as soon as possible.
Okay, so the contents itself we can start after learning the
Yes,
first module, right?
will say that it is largely related to the lab content of the second part of the lab. So
Yep.
we have 2 lab sheets, and it's largely around the same
The
stuff as
LLM one.
the second lab sheet.
Yes.
So I would
Yep.
recommend doing that second lab sheet first, and then
Yes.
going to the assignment.
Yep. Perfect. Thank you. Thanks.
Yeah, Ahmad?
Yep. Sorry if I may ask, is it possible, like, to reschedule the assessment to Sunday instead of Friday? Like, considering most of people, like, working full time all the week.
So in our department, we have a sort of a late policy, um, where it's working days late, and you're allowed to submit up to 5 days late. So if it's due on a Friday, but if you submit it on either Saturday or Sunday, that will be considered 1 day late, and it will be a 5% penalty, but otherwise will be accepted. And if it's due on Sunday, then that will be no days late. I'm not exactly sure. I didn't organize the due dates. I can't change them. But there's not that much difference between the due on the Friday night and due on the Sunday night because department
Oh,
policy
so my
is.
question, because what I witnessed, like, based on previous courses, or like,
Mhm.
assessment was scheduled on Sunday,
Yes.
giving like, all people like, working full time to have like,
Hmm.
this kind of flexibility. And even like, on Friday itself, like, after work, we have also like, scheduled lab at
Hmm.
night. So it's very like, hard, like, to manage time for.
I,
Yeah,
I
yeah, that's right. All the previous courses, all the assignment due dates are the midnight on Sunday, so that give us more flexibility to work on the weekend.
okay. I'll discuss it with Josh. He's this the subject
Three-day
coordinator.
extension there. We can just click on the 3-day extension. So when I click on it, it closes on the 27th of Monday. So we have the whole weekend.
No,
You can do that, but
sorry,
not for
did
assessment one. The other ones,
I did this for segment one. Oh, that's funny.
yeah, I think assessment one doesn't have that. I'll double check, but
I did click on it and they said close it on Monday, the 27th of July. I did it.
there shouldn't be. There isn't. I'm not sure how you got that. Um, in any case, I will discuss with Josh, the subject coordinator, Dr. Joshua Millward, about the possibility of making it the Sunday so that you have that extra weekend, especially considering from now there is only one weekend until it is due, um, and after the lab as well. I'll make an announcement if we are changing that, but at the moment I can't promise anything because it is not my authority to change the due date on the assessment.
Yep.
Uh, Ish, you have your hand up?
Hi, Brandon.
Hi.
Just on the assignment.
Hmm.
So just the way things work. So every assignment, are we expected to do that with the knowledge based on the module that was covered the week before? For example, assignment one can be done with the knowledge covered in module one, or do I have to learn something about module two to be able to do that properly?
It's a good question.
Like
I'm not
it's general
sure.
for all the assignments going
Yeah.
forward. This,
Yeah.
yeah.
So let's have a look. So assessment one is using module one information entirely. So if you've finished everything in module one, you can do everything in assignment one. Assessment two is using everything up to module three. If you've done everything up to module three,
Okay.
you can do assessment two. And then assessment three is obviously due the week after module six. It is realistically probably everything up to module five is critical. Module six is less critical for assessment three. Same deal. Does that make
Yep.
sense?
That makes sense. Just another question.
Hmm.
So the discussion, there was a discussion column under module one. Were we expected to participate in that discussion before we jumped into this lecture, or um
Which one are you talking about?
in
The
module one, there is a discussion at the end?
Supermarkets, I think.
Yeah.
Yeah.
applying, yeah. That is for you to do whenever you get to it
Okay.
in the material. So there's module two, module three, module four. They all have one of those. And so whenever you get to it when you're going through, you should try and do that. Obviously, this is not assessed, so
Hmm.
you can
Yeah.
engage with it as little or as much as you want. It is an opportunity for you to put pen to paper, get your ideas down, and be able
Yeah.
to express what you uh, have learned during the content of the
No,
course.
thank you so much.
Yeah, no problem.
Brendan, just one more question about
Hmm.
assessment one. When you say it relates to the second part of the the assignment. The second part of assignment, it has like we need to connect to T4
Hmm.
section, and there was
T4
limited
instance, yeah.
time. So I
Yes.
was panicking when I was doing that, thinking, well, if I don't finish, so I think the first one I didn't make it. Then I repeat the second time. Now my worry is, what if I have completely used up the time allocated? Like, would you be able to reopen? Like, would Latrobe can reassign
Latrobe
or?
cannot, no.
Okay.
So it is important, and this is at the top of the second lab sheet of module one. We have a discussion about this very point, that you should be very careful with the time you actually use the GPU for. What
Yeah.
I recommend for everyone is to start working and reading through without connecting anything.
Okay.
And then once you're like, okay, I really need to use the GPU right now, then you hit the connect. Um, you do have a limited time. However, um, I mean, it's not great, but it's you can buy you can pay money. It's $15 to get 100 hours of extra
Oh,
time
okay. Yeah. Okay. That's good.
on the GPU. It's a little bit of money. It's not that much, but it's still frustrating, obviously. The assignment should be doable in those hours. We expect it to be doable in those hours, but if it takes someone longer, then that is the pretty much the only option to do is you have to pay the $15 to get
Okay.
those extra
At
hours.
least there's an option.
Yes, that is definitely an option. Yeah, yeah.
Okay. Okay. Great. Great. And you know how many hours is there? Like, what is the total hours we can use
Yeah,
that?
it's if they don't publish how many hours you get,
Yeah.
uh, they just have sort of wishy-washy limits.
Okay.
So on average, I would say if you're doing 4 hours a week, it won't kick you out. So
Okay.
you can use up to four to 6 hours, I would say, every
A
week,
week.
and
Okay.
it's fine. It, it'll be fine.
Okay. Yep. Okay. Thank you.
All right.
Hi, Brandon. Hi,
Sorry.
Brandon. Do we have to do we have to book the lab sessions? In the past, we have never booked. We just come in. Is that okay?
Sorry.
The lab session,
Yes. What about
we
it?
have to book in advance.
You have to book in advance. I'm not sure. You can just come along to any of them. I'm not sure if you need to use if there's Allocate Plus.
Uh,
Just come along to whichever one you like. It's fine.
all right. Okay. That's what we did in the past. Okay. Thank you.
Yep. Okay. All right. We really need to get started. It's been over the time, so we need to get started on the second part. This is lecture two, part two of the first lecture. Um, about microphone's getting a bit weird. Give me a second. How do I sound? Am I okay? Can you hear me?
Yep.
Okay, cool. So the second part of the lecture, we're talking about interacting with modern AI. It's recording everything. All right. So in this part of the lecture, we're going to be talking about the common AI data concept. So how data is represented in a computer, because of course we're doing machine learning. We need to learn from data. We need to know what the data looks like. We're going to go through some common data concepts so that you're familiar with those. Uh, then we're going to talk about modern generative AI, sort of an overview. I'm sure you've all seen it, but we have to cover all our bases and make sure you know what it is, how to interact with it. And maybe we'll cover some stuff you don't know about it. All right. So at the end of this module, we're hoping, this is module two, sorry, it's incorrect. This is second part of module one. Um, we want you to be able to describe what text, images, and tabular data, what they look like inside of a computer, and how those pieces of data can be, how we record relationships between these instances of this sort of data. Separately, we want you to know about some simple prompting strategies, as well as understanding when and how generative AI systems are being executed or could be executed. So let's get into the nuts and bolts. We're starting at the bottom, working our way up to LLMs. What does data look like in a computer? Well, before we even talk about what it looks like, we have to talk about what it is, right? In computer science, we talk about an idea of abstraction. Computers cannot observe the world. We need to directly observe the world. They don't see it the same way that we do. We need to get the world into the computer in some way as data. And so the process of taking the real world and turning it into data that a computer can use is called abstraction. So we have an example here. If we have a human and they're in the real world, there's a lot of information about a human that could exist. But through abstraction, we will be selecting important parts about that human in order to represent that human in the computer. So in this case, we're just going to record a few key details about this human, their height, their weight, their eye color, their hair color, and their nationality. Now, an abstraction is a simplified view. We obviously can't capture all of the information about a human by doing this. No matter what system you use to abstract someone, you're never going to get the full picture of everything about them into a computer. So it's all abstractions are simplified versions of the real world, and these simplified versions of the real world is what a computer will use to perform its actions, right? And so AI models, they can only see a simplified view. Even if that's a video stream of you, that's a simplified view of what you are and what a human is, right? So how you choose to represent a thing in a computer has important effects on what you can do with that information. So for example, when we represent a human as 5 data points, just the height, weight, eye color, hair color, and nationality, can we use this abstraction to determine the BMI of this person? Yes, we can, because we have the height and weight. Can we tell whether this person will respond well to specific marketing material? That's probably a little different. That's probably not so well represented. We probably couldn't tell that information from this abstraction. And so it's important when we're talking about data and what we can do with it, we have to think about what does that data tell us about this, the thing that's being abstracted. Often that's humans that we're abstracting. Because sometimes we can use it, sometimes we cannot. Oh, that is supposed to be the height and weight, it's supposed to be covered. All right. So if we wanted to develop an algorithm that recommends music to someone, let's just think to ourselves for a moment about how we should abstract a human into data so that we can properly recommend music to that human, right? That's, of course, a simplification of the human, but we can obviously do that without seeing a full picture of the human. We can do that without full body scans, for example, right? We wouldn't really, like a full body scan of a human probably doesn't tell us much about what music they like, right? Their age, maybe. Their listening history, definitely. Their friends, what they're listening to, that would probably tell us a lot about what music they might like as well. They might express on social media that they like a particular band, right? They like certain sounds. So those would be abstractions of the person. There'd be data we collect about the person in order to recommend music to them. So that's the idea of abstraction. That's turning something into data. There are some common forms of data representation, which we're going to cover here, which is sort of the base types of data that you're likely to encounter in the wider world. Those three types of data are tabular data, image data, and text data. For tabular data, one instance or one example is a row in a table. The full data set is the whole table. So you've probably seen a table before. We use tabular data in AI quite a lot in sort of the more machine learning, more fundamental AI. For image data, it's obviously images, right? but we're going to look at exactly how it's stored in a computer. One example of it is a single image. And a data set of images is a collection of images that you might find. Uh, your photo album is a data set of images in some sense. And thirdly, we'll look at text data, how text is represented in a computer. And for text, a single example is some string of text, some arbitrary length string of text. If it's short enough, we might call it a passage, or we might call it just a string. If it's longer, we might call it a document. And a data set of text data is called a corpus, usually, or you might just call it a data set of text data. The technical term is corpus. Just thought you'd like to know. So a single example is one string, and then the full data set is many examples of that thing. So let's start with tabular data. I'm sure you've all seen it before, but let's make sure we talk about the some parlance or terminology we're going to use in this subject and in machine learning in general. We talk about instances and we talk about properties. So it's just a table like you might find in a database or an Excel spreadsheet. But when we look at a table, each row is an instance, or also known as an example, and each column is a property. So in this case, let's look at this instance. This is a person, and this one person, their age is 30, their job is unemployed, etc., etc. And we would say that they have 7 properties recorded for that person. And each person has the same 7 properties. This is what a table is. It is the same set of properties being recorded for a series, a collection of, in this case, people, or it might be other things. Now, another thing on terminology, it can get a bit ambiguous. There are different terms. One instance, it might be represented as a list or a tuple, or we might sometimes call it a vector, which we will talk about several times in the subject when we talk about instances as vectors. Don't worry, we'll cover exactly what that means as we go. Next one is image data. So AI algorithms which operate on images are operating on images that are in a computer, and there's really no difference between the form for images for AI as for just general computing. So when you store a image on your computer, it's stored mostly in the same way that an AI is going to use it. And if we look, if we want to know how it's stored, let's look at a very simple image. We have this image of Mario. Just let's think about how do we think this is going to be translated into numbers for a computer? Because of course, ultimately, all of this data is going to be stored as numbers in a computer. How does a computer see an image? It sees an image. Oh goodness, that image is crashed. I'm not sure why it's like that. All right, I'm just going to go out of present mode. See if that... no, it's still crashed when I go into present mode. Okay, I'm just going to do it not in present mode. Pin that down. Can we... Yep, okay, cool. So if we have this picture of Mario, we can see that it's a colored image where there's a different color in each of these pixels. I'm sure you've heard of the term pixel. Well, an image is made up of many pixels where each pixel is actually 3 separate numbers. It is a number for the red, a number for the green, and a number for the blue value. So this top left pixel is white, so it has a value of 255 red, 255 green, and 255 blue. And each of these pixels in this image, they're all the same. They have 3 different numbers associated with it. And you can think of it different ways. You can think of it as each pixel has 3 colors, or you can think of an image as actually 3 separate color maps. So in this case, Mario is this red map plus this green map plus this blue map. And in the lecture notes, if you want to, you can zoom in and have a look at the exact values. This is exactly the colors, exactly the numbers that result in those colors for this Mario image. So what's important to know about an image is that it's actually a three-dimensional data structure. It has the height and the width, right? Height and the width in terms of number of pixels, but it also has a color depth to it, right? It's three-dimensional. It has that color depth. So when we use images in computers, it has three dimensions to it. All right, text data. Let's see if I should be fine now. So I'm just going to keep going with text data unless it also, okay, now text data is also busted. All right, so text data, it's a very common piece of data. You know, when you write an email, when you type a message to ChatGPT, when you type anything into any part of a computer, this is all text data. Now remember, computers ultimately store everything as numbers. So the question is, how do computers store text as numbers? For the normal case of computers, so not AI, just the normal case, one approach is called ASCII encoding. Other forms of encoding, which is also based on ASCII, as Unicode encoding, which is how you get emojis. Basically, all text, all of the characters of text are stored as some integer whole number ID. So if we have this text, hello friend, what the computer's doing behind the scenes is it's taking the character H and it's encoding it, the capital H, encoding it as the number 72. And so it stores down, okay, the first character to show here is 72, which represents the H character. And what's important about this is that it's entirely one-to-one. You can take any string of characters, turn them into a string of numbers for the computer's sake, and then transmit them somewhere else, and then convert them back so that the person on the other side can read the message, right? And you can decode it, and it's exactly the same. It's identical. There's no changes to it. So it encodes and decodes with exactly the same. So this number 72 in ASCII always, always, always means the capital letter H. ASCII is not the only way to do this. There's Unicode and other ways. We'll look more at encoding text data. This basic idea is roughly how it works for AI algorithms and LLMs, but it's a little more complicated. There's a few extra steps, and they don't quite match what we do here. But the basic idea is the same. You need to convert your text into numbers for the computer algorithm, and then you convert it back, and the computer algorithm works on those numbers, and then you convert those numbers back into text for humans. All right, so those are the three types of data that you're most likely to encounter using AI or just general computing. Now we're going to talk about how we represent relationships between that data, because data in general by itself doesn't mean anything. We generally want to find relationships. We want to use relationships to do computing, to be able to figure things out. So we've just seen a bunch of instances. We want to now think about how we might use a computer to represent how they are related. That can be useful for finding songs that are related, people that are related, different documents that are related, rows in a database that are related, right? We want to be able to understand when they are related. Ish, I'm going to answer that question later. So the first form of relationship we're going to talk about is the graph relationship. This is a mathematical concept, this graph. And all a graph is defined by is nodes and edges. So nodes being your instances. So that might be a row in a database, or it might be an image. And then edges is just a relationship, and that can be pretty much any form you like. It could be a single number, it could be multiple numbers, it could be itself another row in a database, this edge. But the important part is that it's what defines the relationship between the nodes. And so in the top right, we have two separate graphs being shown that are connected together. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes in it with relationships between those. Now, when you're looking at a graph, something important to note is that when you draw it, how those nodes and edges are drawn the only thing that's important is which nodes are connected to which other nodes. That's the only thing that ever gets recorded in a graph, is which node is connected to another node. So a fun thing is that these two graphs are actually identical information. They have the same nodes. You can see this purple here is attached only to this orange node, right? Only to this orange node. And this orange node is connected to three other nodes, this darker green, this lighter green, and a lighter purple. And you can see that's the same thing. This orange node is connected to those three other nodes, which is how it's connected. So this is what defines a graph. It's just the nodes and which nodes are connected to each other. And so it's some examples of that you might come across. Social networks. So you can describe how people are connected on Facebook, where the people are the nodes and the edges, the relationship if they're friends or something. And you can also describe molecules like this, where you have atoms as the nodes, and then you have like a covalent bond or a, goodness, my chemistry knowledge, covalent bond, or I can't remember the other ones. There's other kinds of relationships between atoms where instead of sharing the electrons, it's just like an ionic bond. That's one, ionic bond, where they just are held together by their charge, but they don't actually share the electrons, etc. So another graph could be a skeleton where you have different joints. Again, abstracted joints. Yes, the ionic bonds. Abstracted the joints because obviously there's more joints than this, but you can describe a person like this. And so if you ever see pose from video, this is how people are represented in those pose from video works. So a special type of graph, which is particularly relevant for machine learning, is a tree. Instead of, so in addition to those relationships between the nodes, in a tree, there is a direction to those nodes, to those relationships. And especially when you have a tree, it must be that when you follow those directions of those relationships, you can never return to where you started, right? So you always end up at an end of the tree. So if we have here, this is a recommended daily intake calculator for iron. If you want to know how much iron you should be eating every day, you can follow the instructions in this tree. You start by asking, okay, what is your age? Is it 0 to 13 or is it over 13? Okay, if it's over 13, I'm just going to do myself here. Okay, I'm over 13, sex, male, female. I'm male, so I follow that node. And then my age, if I'm over 19 years of age. So my recommended daily intake is this 8 milligrams per day. This structure where you have these nodes with directed relationships and you can never return to where you started is called a tree, and it follows those things. And we will use some trees in the next module. So you'll see some trees being made using machine learning. So you can, it's sort of a graphical, this is a graphical representation. You could also think of this as being a bunch of if-then statements. If age is 0 to 13, if age is 0 to 6 months, do this, right? If it's this, do this, right? So it's identical. There's a one-to-one mapping, completely identical. A tree can be represented in code as a bunch of if-then statements. And so that means it's very good for decision making. It's like you can write this down, you can see it as simple rules in a computer, and you can understand exactly what's going to happen given any sort of input. So this is a very simple form of AI. Early forms of AI were really just this sort of system where you have these if-then rules, which is a tree. As I said, they're one-to-one. So they can be used for decision making, they can be used for classification, and they can be used for searching things. The third kind of relationship is kind of no relationship, or no explicit relationship. And that is called flat lists, is what we'd also call it. So I think of a table, you just have rows in a table. Usually there's not actually like an explicit relationship between the rows in the table. And often part of AI is trying to find the relationships between elements in a flat list. Flat being the structure right? If there's no structure, it's flat. These other relationships have structure because they are related to one another and they have some sort of shape in a sort of abstract sense. They have some shape to the relationships. A flat list sort of has no structure to the relationships. It is flat. There's no structure. And so, as I said, often what we're doing in AI is we're trying to find relationships between it. So we take a flat list and then we induce a structure on it. And what we get from that is often, what we get from inducing a structure on a flat list is called a vector space. And if you're confused right now, don't worry, it's a bit confusing. And also, we will be coming back to this later in the subject. It's very important that you know vector spaces, so we will cover this again in much more detail when we start talking about LLMs. This is a very important concept for LLMs. So what we want to do is we want to create a vector space. This is an example of a vector space in 2 dimensions. If we have a bunch of people and all we recorded is their height, their weight and their height, then we can represent each of these rows as a point in a 2D graph, right? So this 86.2 weight and 169 height. So 86.2 will be about here, and the height is 169. So that person's probably like one of these points around here. If you can see my cursor, I'm not sure if you can. One of these points around there. Hopefully you can figure it out if you can't. So this table, this tabular data, can be represented in a 2D space. And we can see that in here, we have some of these points are closer to each other than others. And remember how I said there's no explicit structure. There's no explicit relationships or structure between these rows. There's nothing saying that this person is related to that person. But if we look at this graph and we look at how they are presented in this space, we can kind of see some sort of implicit structure going on here. And it is, in fact, what AI does, especially machine learning algorithms, is processing these positions to learn a structure on this space, learn sections. Maybe we'll group a section and say this section here it means something, and this section here means something else. For example, if we're talking about BMI, we can color this space based on classifications. In this case, we're not learning anything, but we still have classifications that are defined by someone. In this case, Australian government has defined these regions of BMI as being underweight, healthy weight, overweight, or obese. And so there is some sort of implicit structure that's going on in this space between what was rows in a database, rows in a table. There is this structure between them that these ones are all kind of the same. We're going to treat them all the same. If these people are overweight, that puts them at a higher risk of some health issues, right? And so that's hopefully a useful categorization. Maybe it's not useful in some ways, but it is a classification that's used for assessing health. And so this is the last and more complicated type of relationship. It is this vector spaces. I'm hoping that makes sense, at least a little bit. And as Nick and Jay has mentioned, there are embedding models, which is what we will talk about later on in the subject when we're talking about LLMs, which create these vector spaces, and not just in 2D, but in 3D and more, and even up to 1,000 dimension. And so you'll get some practice basically thinking in 1,000 dimensions, which hopefully sounds fun. One last point on these vector spaces. When it is learned, when there's a model that is learning how to do this vector space, so it's not just this classification like this, and it's not just a table that we already have data to put it in space, but when we are learning vector spaces, an important concept, and we'll cover this again later, is that in these vector spaces, what the model is essentially going to do when it is learning the space is going to place instances that are more similar closer together in the space and place instances that are more different further apart. So if the model takes in an image and it will produce a vector space location, a point for it, then images that are more similar will be closer together in that space. And again, we'll be doing this later on to look at that in more detail, and we need to move on for that. Okay. Right, so yeah, if you have a three-dimensional table, a table with three columns, then that would be sort of a point in three-dimensional space, which is a bit harder to visualize. We could maybe still do that. We could maybe still visualize in 3 dimensions. But if we have a table with 7 numerical columns, each row in that table can be thought of as a point in 7-dimensional space, which we cannot visualize. Anyone who claims that they can is lying, but we can get used to thinking about things as being in this higher dimensional space because all of the maths ends up being the same. Basically, distance, measurement from one point to another, in 3-dimensional space or 2-dimensional space or 7-dimensional space, it's always the same equation. It's always the same way of calculating, the same idea. This point is close to another point. It's far away from a third point. And it's that closeness and that distance that really matters. And so that's why we can think in higher dimensional spaces, even if we can't visualize it. All right. For the last 20 minutes, we're going to be talking about, we're going to have a sort of broad overview of the modern generative AI, how we interact with them. So there have been some recent advances, especially since 2022 with the LLMs coming out, that have pretty dramatically changed how people can interact with computers. Now we can write in human natural language instructions for a computer, and it can do some pretty impressive things. It can obviously generate text in response, but it can also create images for us. It can write code for us. It can do approximately kind of almost anything that involves just operating within a computer to greater or lesser degrees of success. So something I want to talk about, and just to give you a bit of context of like why has it only come up in the last really 4 years? Why has it taken this long to get to where we are? And there's 4 things that we generally say has caused this current wave of the newest AI algorithms working so well at what they do. Even though they fail sometimes, they are obviously the best algorithms we have at these jobs available. And there are these 4 things. Obviously, we've improved the algorithms slightly. We've tweaked numbers. We've gotten training techniques to be able to train the model better, figuring out better ways to represent data and to represent the calculations that it needs to do internally. That's obviously an important part of what we're doing, what we've done. Another big part is that there's been more training data available. We've all seen like Moore's law, computing, the amount of data on the internet, the amount of computing power we have has been improving and increasing all this time. And it just so happens there's like a threshold that we need to get to enough of actually these last 3 things. We need to get enough training data. It has to be big enough training data. It has to be fast enough hardware to get through it fast enough. And we have to use large enough models to eventually get to something that works pretty well. And can you guess which of these, out of these 4, is the most important?
I
Hardware.
guess that was the faster hardware.
Training data.
It's the training data.
Yeah.
That is the most important. Without the training data, we could not do anything. We could have the best algorithms in the world. Eventually, and even if we had slightly slower hardware, we need this training data to represent the world. The least important unfortunately, for computer scientists, has turned out to be this.
Mm.
Turns out that if you have enough data, enough hardware, large enough models, and you're just training relatively the same algorithms we've been training roughly the whole time, you can get pretty far along the way. Obviously, you can't get all the way. There have definitely been improvements, but it has really turned out that like it's these other ones that are more important.
Which training data, what about the training data has improved?
Volume and coverage, and volume and thus coverage. So we talk about this in the module notes. I think it's in module 2 that we really get into it in detail. But the job of your training data is to represent the world correctly. We've just talked about how instances of things get represented in a computer by abstracting them. That is a process of simplification, and we're potentially losing some amount of the real world. When we have a collection of data, which is a bunch of instances, what we need that data to cover is all of the different possible variations of those abstractions so that it knows what to do in every single case. And so it's sometimes very difficult for us to really understand how much data is necessary to properly describe the full breadth of what should be represented even in those simplified abstractions. So you have the abstraction of a human being those 5 properties. We can sometimes forget just how many rows of data we would need to show every possible combination. Well, not every possible, like almost every possible combination, or the types of combinations that could exist across the entire world. And so that the main thing that's happened here is coverage and
Okay.
sort of recognizing that we hadn't covered all of the real world before, and now we've covered enough of the real world with our training data that the models can learn from it.
From my naive point of view,
Sure.
I thought there was loads and loads of training data out there. The internet was invented. It was creating so much text data that we could process, so much image data that we could process. So what actually shifted with the amount of text data, image data that actually made LLMs possible?
It was standardization and putting it into a ingestible form so that you can train on that data. So yeah, there's a bunch of text data and a bunch of unstructured text data out there.
Yeah.
But it was just sort of on a bunch of web pages. It was on Reddit. Like the actual thing that allowed people to use it was somebody went and ran a program to scrape all of that from all the
Yeah.
web pages and
I
put it
assume
all
so.
into one big file. And it just people hadn't done that before. And then
Okay.
we got that.
Actually,
When
Brandon,
we
just a question.
Mhm.
The lecture also mentioned about zero-shot trade learning, right? So
Mhm.
is that zero-shot learning is about data or about the algorithm to be able to do something that it hasn't been trained?
I will talk about that later in this lecture, so if you don't mind, I'll just
No, I mean, I'm
put a
just
pin on
wondering, right, because you talk about training data is
it.
important. With the
Um,
zero-shot, isn't it training data becomes less important?
in zero shot training, in zero shot, I want to answer that question when we get to it. It'll make more sense when I talk about it in the context that it is. It's only a couple more slides.
Okay. No, sorry. And one more question, if it's not jumping ahead or anything, is
Okay.
that is this training data open source and available, or is it proprietary?
For the most part, the early forms, the early LLMs, so when ChatGPT first came out, that
Yeah.
was all using publicly available data, which they did not have the rights to use, technically. But it was all public available. It was all taken from publicly available web pages. Since ChatGPT has come out, and obviously people are trying to get a competitive advantage for their models, there are a bunch of models that are trained with some unknown proportion of proprietary data. But the original ChatGPT and all of the open source models are all using data that is all publicly available. So it's entirely possible to have very
And
functional,
and
very
hence
powerful LLMs
hence my
using
my
open data.
my my inability to grasp that it's the training data because it's always been publicly available.
Of course,
So
you do
is
need all of
there
these things. You do need all of these things to work
yeah
together. That's true. You need all of these things to come together. The data wasn't the volume of data has increased dramatically. Every year there's like an almost like 50% more data on the internet. So
yeah no
so
right
10 years ago there was a fraction of the data available on the internet. Anyway, right, I do have to move on. So if
thank
you
you
want to discuss it more, you can talk about it in the forums, but I do have to move on. We're really running out of
cool
time here.
thank you
All right. And it's not letting me change the. Okay. So these models, they're trained on an enormous amount of data and they have that big coverage that I mentioned, right? Um, they can, with the full scraping of a large swath of the internet, right? Especially for LLMs, it covers a huge number of different possible tasks that the model might be able to do. And that's how we get these large language models, which are able to do many different things. You can ask it to write poetry, you can ask it to help you with your maths homework, right? This is the same model that is able to do both tasks because it has been trained on data that is writing poetry and on data which is answering maths homework questions. And that makes it what we call a foundation model, which is that it can be used, we can further train those models we wanted to onto other tasks if we have specific training data that we need it to work on. But the main point is just that these models, because they've got that huge wide range of data on the training data, that is what gives it that sort of general applicability. In addition to a wide range of different tasks, there's now a lot of multimodal AI, which is not just accepting text, it's accepting images and audio and video. And later in the subject, we will show how those models are able to process text and images together. But of course, in having these different modes of data coming in enables different types of tasks, which again, the model needs to have data to be trained on. This is often where those proprietary data sets come in, or yeah, this particular interaction for multimodal AI. So this is in contrast with the traditional AI, and we're going to talk about the more traditional ML, machine learning and deep learning AI in the subject. But to give it a high level view, the traditional AI is, and machine learning and deep learning, they're all just like you have one model for one task. You have very structured data which you train, which you use to train the model to do that one task, which means that that model has extremely specific knowledge about that specific domain. Um, if you can indeed call it knowledge, it's arguable. You can debate that if you like. Um, I'm going to use the term knowledge, anthropomorphizing it a little bit, just makes it easier to talk about, not that I think that it is actually conscious. That is in contrast to the modern generative AI data, where you have one model which can do many different tasks. And instead of interacting by giving it, say, a row in a database, so you give it a row in a database, with the traditional AI, you give it a row in the database and it'll tell you some prediction for that person, which is the row of the database. Instead of doing that, you can interact with natural language, you can interact with showing it images, you can interact with this sort of more unstructured data, and it sort of knows how to handle that. And instead of that extremely specific knowledge, these general AIs, they have sort of an approximate knowledge of most things, right? And that's sort of the big difference that's happened recently. So now that we have got that separation, it's obviously useful to know how to interact with these LLMs. In some sense, it's very simple because you just open a prompt and you type, right? There is a little more to it, but quite honestly, there's not a heap more to it. There is just one key concept you need to know, and that is even a perfect LLM, even if it was perfect in every way, it would not be able to read your mind. When you are instructing an LLM to do something for you, you need to write it so that you get what you want. It can't read your mind about what you want, so you need to specify everything which you want from it. So if you say write a story to the LLM, it can write a story, but it's not going to cover exactly what you want from it. A better prompt would be, write a 300-word mystery story for first-year university students set in Melbourne with a surprise ending. That prompt obviously will be more specific. It'll tell it how to achieve what you want. And so prompt engineering is really just a process of figuring out how to express in human natural languages what is it exactly, what is it exactly you wanted from it? And that can take a few iterations. You think you know what you want, and then it'll do something different, and you go, oh, yeah, okay, actually, I wanted it to do something different. And so we give you 4 key guidelines for just getting a good prompt to start with and to improve it. The first and most important guideline, of course, is to be specific and state exactly what it is you want from it. Just be clear in your language as if you're talking to a human. If you're trying to tell a human how to do something, you also need to be clear. Same thing with talking to an LM. You need to be clear about what it is you exactly want it to do. And it'll tell you if, or it will do it wrong, I suppose, sometimes if you're not clear enough. The second guideline, and this is one that people often forget, but it really helps a lot, it's to set a role and an audience for it. So you need to tell it, hey, I want you to behave as if you are a university tutor. And you're going to tell me, a university student, how to do X, right? When you tell the model what role it's supposed to take on and the audience it's supposed to be communicating with, the results can be much more tailored to it. This is basically a mirror of writing advice, if you've ever heard it, is know your audience. You need to know who you're writing to so that you can tailor what you're saying so that they will most be able to understand it. And that's what you have to tell the LLM. You have to tell it, who are they writing to? And the third guideline is to set constraints. You want to specify different things. You want to specify the format, the style, the length, or any other extra constraints you have on it. This is when you think about you're writing a prompt for it, often you'll realize that you do have some constraints you want from it. Maybe you want it to be as brief as possible. Maybe you want it to always respond in as few words as possible. Well, then you can tell it, respond in as few words as possible. It also is useful if you want to ingest the output of an LLM into another program or something. You can tell it, hey, I want you to respond using this particular format, and it will be able to do that for you. So those are the 3 main guidelines. And then the last guideline is you're probably going to have to iterate and evaluate. Honestly, the different prompts will behave differently with different LLMs. So often you will create a prompt for a specific LLM and you'll try it out a few times, see what it does right, see what it does wrong, and try to refine it a little bit, see if you haven't defined the task properly, etc. And I will note that all of the big major LLMs, they all have their own prompting guides. They have their own set of instructions to guide you to writing a good prompt. These are the guidelines that are sort of common across all of the different LLMs. As I said, really the key single fundamental idea is expressing to the LLM exactly what you want in English or in whichever language you speak. It could be English, Chinese, whatever. We are out of time. I won't be doing a demo for that. I'm sorry. So again, that's key ideas. There is no magic recipe. You just have to communicate what you want to it clearly. And we've just talked about LLMs, but those same ideas apply to generating image, generating code, etc. You want to be extremely specific. If you ask for an image of a cat, what kind of image? Is it a photo? Is it a painting? What is the composition of it? Is it a big cat? Is it a small cat? All of this information, it would have to guess. And so you have to sort of think about these things. Especially for images, you will want to sort of brush up on your different mediums. If it's a painting, is it painted in a style? Is it hand drawn with colored pencils? Those sorts of things you want to specify. You even have to usually specify that you want a high quality image, right? Because been trained on a bunch of images on the internet. So you want to tell it, okay, I want a high quality image that looks like it was taken by a professional photographer, right? That sort of information. You need to specify that because otherwise it doesn't know. The last point, I think this is the last thing we're going to talk about for ViewShot. Yep. There is a difference between what's called a system prompt and a user prompt. We'll look at this more later, but I do want to do a bit of a demo here because it'll be very useful for you in the labs. So we have system prompts and user prompts. The system prompt, the purpose is to set the LLM's overall behavior. It is written by a developer. If you just go to ChatGPT, there is already a system prompt in there that they've written for it, telling it how to behave, how to respond to the user. So for ChatGPT, if you just go to it, or Claude, if you just go to the website and you type in a message, they have got instructions for it that tell it, okay, you're going to be like talking to the LLM, you're going to be a helpful assistant, and you're going to receive requests from random people on the internet, and they're going to ask you questions. They're going to tell you to do things. We want you to be friendly and helpful, and you should never swear at them, and you should never tell them information that might harm them, all of that sort of stuff. They've written all of that down in English, or often English, I guess, because they're English developers. For the Chinese ones, they're usually written in Chinese. And they're not visible to you, but they are guiding how the LLM will behave. And that's called the system prompt. What's important about that is that it's just like the user prompt in the sense that it is normal English language, and it's just telling it how to behave. The difference is in its purpose. So its purpose of the system prompt is to set the overall behavior. When you go to use an LLM, what you type in is called a user prompt. And that is a specific task. It's written by you, and of course it's going to change every time you use it, whereas the system prompt is the same for everyone who uses that service. Now, the thing I wanted to show you was that if you wanted to use Gemini inside of the lab to help you or to assess your answers to the questions, you are allowed to do that. However, if you do that, I would recommend that you go to, that when you do that, you change the system prompt. I can't find it. All right, I'll have to show you how to change the system prompt another time, but I will show you that inside of the notebook, it comes with two separate system prompts already baked in that you can swap between. Well, three actually. There's the general one, and then there's specific ones for this. And there's learn mode. So when you're going in, and if you want to use AI assistants to help you with the lab, I would recommend enabling the learning mode thing, which is really just a different system prompt. And it tells it, you are an expert college-level coding tutor known for your patience and ability to clarify complex topics. Your primary goal is to foster deep understanding. So this is different to the normal one. So the normal behavior of the LLM would be to just answer any question and tell you how it works. The learn mode, the purpose of it is actually, instead of the core guidelines number 1, never give an answer directly. You must withhold code and solutions and direct answers. Use Socratic questioning to guide the student to discover the solution themselves. This is much better for learning. I would say that the default operation of LLMs is actually very bad for learning. This kind of thing, I've written a few different versions of these system prompts before, this kind of thing is much better for learning. So again, I would recommend, if you want to use AI, you don't have to. If you want to ask Gemini, and I can't remember how to bring up Gemini on the side. If you want to, you can. Just make sure you change it to learn mode, and it will help you out with the learning quite a bit better, quite a bit more. Okay, we are out of time. We need to go to the lab. I'm very sorry, the last slides. I will very briefly go through them, just so that we have them down, and I apologize for taking too long. It's my bad, I should have kept to the time. Zero shot versus few shot prompting. We talked about how these are very general models. Zero shot means that we have for zero shot prompting, we are talking about giving the LLM a task without giving it any examples. You won't be able to look through those. I'm just going to say it out loud. Zero shot is not giving it any examples. Few shot prompting says I'm going to give the model a couple of examples of what I want it to do, and then that will help it to understand what it's supposed to do. That's zero shot versus few shot prompting. Historically, we talked about zero shot learning and few shot learning, and that's with respect to that more traditional AI when we were trying to get models that were more like these foundation models, right? We wanted a model where we could train it on some data and then make it run on a new task without showing it any more new examples and without training it on any more examples. And that's called zero-shot learning when a model can do that. And basically the modern generative AI models can kind of do that. So they've kind of made processes of zero-shot learning or specific processes of trying to do zero-shot learning obsolete. But in order to do this, we of course needed LLMs that were much larger with much larger training data, as we talked about. And so the last thing I want to talk about very briefly is when you run an LLM, you should try and keep in mind where the model runs and how you're going to run it. So if it's a very big model, you kind of have to run it in the cloud. Remember I said before that the cloud is basically a data center somewhere with a bunch of computers, a bunch of GPUs. If it's a cloud-based thing, you're going to be interacting with an LLM on a computer somewhere else. But theoretically, if you had enough computing power or if you had a small enough model, you could actually run it locally on your own machine. And so there's different tools to run LLMs in these different scenarios. So on the left, there's local, on the right, there's remote. So if you install A111 for image generating or LM Studio for interacting with LLMs, you can run these things on your computer. Your data doesn't go to a data center anywhere. It's just all running on your computer. Of course, you need to have a beefy GPU to be able to do that, and you can only run reasonably small models to do that, but you can run it locally. On the other side, you've got remote. Basically, if you go to a website and access it, you're basically accessing it remotely. You're sending your data to another machine in the cloud on those computers in the data center, and those computers in the data center are running it and then returning the result back. But those are GUI applications. Those are just users typing in. Theoretically, if you want to use these systems, you can also write code to interact with these things. And you can similarly run code locally, or you can run code to interact with the remote servers and do that automatically. And so you have this sort of grid of different situations. You can run code locally, you can run code that runs it remotely, etc. Sorry for having to go through that so quickly. Summary. Overall, you should be aware of those three common data types. You should know what tabular data looks like, you should know what image data looks like, and you should know what text data looks like. You should know that relationships exist between data. They can be represented explicitly, as in trees and grass and trees, or they can be inferred by a model by similarity, such as in vector spaces. And finally, modern Gen AI is incredibly capable. Of course, we need to think about prompting and where it's running. Okay. That is it for the lecture. I apologize for the very big rush at the last few slides. We do need to go to the lab now. So I'm going to actually, if you have any questions, I'll briefly look through the chat. I see you've been talking about things. I'm going to answer.
Thank you, Brandon.
Bring your question to the next lab, and I'll answer it. Answer it there if you want, or you can put it onto the forum. I apologize for how late it has gotten.
Thank you, Brandon.
Thanks, everyone.